I wasn't recording, so now I'm recording, which is great. Okay, can you go through once the process of saving code in GitHub as exercise 2? I can try to when we open the editor in a bit. Yeah, how do you submit the homework? You're going to add it in GitHub, which involves typing the code, git add, git commit, git push. I can show you how to do that when we open the code editor in a minute. Yes, pushing your code is the same as submitting an assignment. And the reason for that is because I'm not like directly checking all of your assignments, meaning like I'm not going to give you a score or anything like that, but I am reading all of your assignments. So hopefully you're all feeling the love of me reading the assignments because I've reached out to a ton of you about how you're doing. So if you want feedback about the thing that you're doing, just push your code and I will do my absolute best to reach out to you. I'm wondering if the homework on Thursdays are going to be harder. RB, I think that generally that's probably going to be true. Although given how many questions we had about functions and loops yesterday, we're not going to do that this Thursday. So your homework is going to be either non-existent if we don't get to the place that I want to get to, or fairly easy if we do get to the place where I want to get to. Kevin D, yeah, I mean, if you want feedback, just push that code. Otherwise, I'm happy to have you either way. Yeah, Lil, I did actually see your repo. So Lil says that pushing the assignments as GitHub has been my issue as well. I saw a lot of people updating kind of the README over and over again, which indicates to me that they are figuring out the push step, but they're not figuring out the add and commit step. I realize that can be confusing, so I'll go over that in a minute. If you haven't gotten any feedback yet, it does not mean that you did bad work. It doesn't mean you did good work. It just means that I maybe missed your thing. So let me just give you a little bit of like inside baseball on how I'm actually seeing when they're new. The repositories, in my view of GitHub, are ordered by when they were last updated. So the way that I'm going through your repositories is I'm remembering who I saw last, and then I'm going through all the repositories between that person and the top. So if someone gets lost, it is not any kind of judgment on you. I can't reach out to all of you every single time because there are a lot of people in the class. But if you want feedback directly and I haven't reached out to you, just DM me on Slack and I'm going to give you feedback. Visual Studio Code is the editor that lives inside of the browser that we're using in Codespaces. If I have not reached out to you, it means one of a couple of things. It either means I didn't see your submission, it means that you don't have any code in there, so it just says something like puts hello world, or it means that actually it's just those two things. If you have code in there, it's either that I didn't see it or that there's no code. Someone says if you want to get there, I think you should ask less digressing questions. I'm going to be addressing that as the class starts here. I'm going to talk about feedback on GitHub at some point, but not right now. And Andrew, let's talk about that at the end of the course. Yep, that's a good point. Anonymous attendee says, if you have questions that you think could distract from the thing that I'm trying to teach, just please keep them in the questions repository on GitHub. And again, we'll talk about that again in a minute. Okay, but in the meantime, we have a special guest. So Denise is a senior software engineer at GitHub and has been working with me. Denise, I'm going to promote you to panelist. Hopefully this works. Awesome. So Denise has been working a ton with me and another group of people at GitHub on our diversity and inclusion interview, which can be disheartening and satisfying and all types of emotions all at the same time. But Denise has very nicely come to talk with us today. So she's going to spend some time introducing herself, and then we'll take some questions. So thank you, Denise. I hope your audio is going to work okay.
Should work. Can you hear me?
Yes.
Okay. I haven't changed anything about since my earlier Zoom calls in the day. So hi, everyone. My name's Denise, as John introduced me already. I've been at GitHub for about a year. I actually joined almost exactly 1 year ago. So I started a new job at a fully distributed company in the middle of a global pandemic, which was a lot of fun, as you can probably imagine. At GitHub, I've worked on a couple of different teams. I was actually hired at GitHub to join a team called Community and Safety, which is kind of, if you've ever heard of like trust and safety engineering, that was GitHub's engineering arm for doing that. So as part of the community and safety team, I got to work on some really cool features that mostly center the mission of that team was to make GitHub a safe place for communities to grow and for users to get their work done, essentially. Obviously, it's not a lot of fun if you're just trying to use GitHub and you're being barraged by a ton of spam or a ton of like nasty messages. So community safety is a team that built things like user blocking, the ability to to report spam, rather, not to mark people as spammy, but to report spam that you encounter when you're like working on an open source project, and a lot of other user safety features in that vein. I currently work on a team called Communities, which is actually a department with many different sub-projects. I'm still building tools for maintainers, but the focus has slightly shifted away from not necessarily, like we don't focus just on user safety. We focus more broadly on making GitHub the best place to grow and maintain open source communities in a sustainable way. So the feature I'm currently working on is one that's actually in limited alpha, and I'm really excited about it because I get to hype it up a little bit. But if you've ever gone to an open source repo before and you want to open an issue, you might say like, okay, I want to make a bug report. In some cases, you might encounter a really large pre-filled text box, which is actually called an issue template. You had to like delete parts of the markdown and put your own inputs into certain places, but you couldn't delete other parts of the template because the maintainers like really wanted people to answer certain questions. So my team worked on a feature where we essentially replaced that experience with a web form. So that's a more it's a more reasonable experience for everyone, because for maintainers, they now can say, I actually need you to fill in information like what version of the software are you using. And for contributors, it's way easier to manage because you don't need to be an expert in writing Markdown. Everyone kind of has some baseline understanding what a web form is. And so there's a lot of advantages to using that approach versus a pre-filled text box in terms of like usability and accessibility as well. So I'm really excited to be working on a lot of features like that. Yes, there is a cat in the background. He is very passed out. It's kind of his bedtime all the time, which I think is a pretty blessed life for a cat. Before I worked at GitHub, I want to talk a little bit about my background because I have a non-traditional route into working in tech. I actually studied economics in my undergrad, and I did a master's in policy after. And I kind of stumbled my way into tech by way of a 12-week boot camp back in 2014. I was living in the UK, and I kind of signed up for a coding boot camp because I thought it would be fun. Like, I actually wasn't trying to career switch at the time. But I found that like being able to solve a problem with code and being able to like build something from nothing was completely different to how the world of law and policy worked. Like coding and programming and technology felt fast and empowering, and like in some cases, like we hear the phrase like move fast and break things, and to some degree, like that is very, very true. If you can almost move like irresponsibly fast in the world of technology, and I do think that there is value in slowing down and trying to understand like what are the problems we're actually solving, who's going to be impacted by any given solution that we build. So that's kind of like what I'm glad that I came into tech from a non-traditional background, because I spent a lot of time thinking about the kind of like societal and moral and ethical issues around creating policy for a long time before I started writing code. So yeah, I don't want to sort of like ramble on for too long, but I'm happy to answer any questions about what it's like to work at GitHub or what it's like to work at, I guess, like tech companies in general. I've worked at a number of different companies of different sizes, like startups, early stage. GitHub is not really a startup anymore. We're pretty late stage and established. But I'm, generally happy to answer any questions that you all have.
I love what you're saying about the morals related to writing code, and that like I think a lot of times developers have a hard time separating I can do this thing from I should do this thing.
Exactly.
And it can be very complicated.
Mm-hmm.
So it looks like we have some questions coming in. Can you access them?
Yes, I can see.
Okay, great.
Okay, cool. there's no upvoting system, right? So I can just choose randomly.
Yep. You can choose whichever ones you think are good to answer, and we have about 10 minutes. Although, like, I'm not going to cut you off, so like, just keep going.
Okay, cool. There's a question from Jada. I hope that I'm saying your name right, Jada. Was it hard to grasp what was being taught in your bootcamp that you were enrolled at? Like, how was your experience starting from zero? Yes, it was extremely hard to learn. I'm not gonna lie. Some people kind of take to it. Some people don't. Like the on-ramp is so different for every person. For me, the one thing that made it a little bit easier was actually, I studied both economics and philosophy when I was an undergrad, and I took a lot of classes in logic when I was doing my philosophy major. So it turns out that like mathematical reasoning and like thinking about things in terms of symbolic logic does actually translate to code, because that's conditional logic when you start writing if-then statements. But that was like literally my only foothold, and there's way more to programming and to software design than just like understanding how an if-else statement works. It was really, really hard. I'm not gonna lie about that. I really doubted my like ability to learn and my own intelligence and my own capacity, like every step of the way. And I think like it wasn't until I managed to get my first job within 2 or 3 months of the boot camp, but that's not the point at which I was like, oh, like I got this, like I can totally do this. Like I think that kind of feeling insecure and feeling like I might not have this thing completely figured out, like I still have some days like that. I definitely still have days where I'm like, how do I write like, I don't know, this operator in Ruby? So still totally Googling things. But I think that the thing that helps me to keep in mind is like, the only person that you have to prove anything to is yourself. Like, I think we're way harder on ourselves than anyone else will ever be on us. So on the days that I'm being really harsh on myself, I kind of like stop and I'm like, okay, would you actually verbalize what like these really harsh ideas and criticisms in your head, would you actually verbalize that to another person? Okay, no, like, of course I wouldn't say, the things I tell myself to another person. So I think like level checking and just making sure that you're treating yourself with the same kindness that you extend to other people is a huge part of being able to do this thing, like being able to learn and being able to succeed in a way that's sustainable. I hope that helps. Okay, so Asaya, I also hope I'm saying your name right, asked, what helped you transition to your first software engineering role? Did you have support systems in place, mentorship or company support? I think that's such a great question. For me, actually having the community from the bootcamp was really critical for me. I am not sure that I would have successfully made the leap into a full-time job if I didn't have, my cohort of like 24 other people that were on the course with me, and also we had. There are people who like work for the bootcamp whose interest it was for us to get employed so that they could say that our bootcamp is successful. But like having that layer of staff who were there for us and who had industry connections and were willing to like, put their necks out for us was huge. I think kind of more broadly, if you don't go through a bootcamp route, if you don't have like dedicated support staff, another way that I found I've been able to find supportive networks are actually through Twitter. I know it's weird, like Twitter is kind of a tire fire most of the time, but if you kind of like, if you are really selective about who you follow and you kind of like try to avoid, the parts of Twitter that are more on fire, I think you actually can find people who you can like almost like make friends on Twitter and network and find people who are willing to vouch for you, or who sometimes like all you need is a retweet, honestly. Like all you need is the right person to see your tweet. And like I helped someone a few months ago who there was a friend of a friend who was looking for her first job, and she's like, do you have any advice for me? I've already like exhausted all the traditional channels. Like I have like nobody in my personal network really knows how to make a connection. I was like, you know what? I want you to do this one thing. I want you to write a Twitter thread where you introduce yourself, like say something, share what you're willing to share, what you're comfortable about, like, your personal life. Like I live in this country, I have 2 cats, like I love this TV show, like whatever it is. And then be really specific about what your skills are and what your interests are. Because even for like getting your foot in the door for your first job, that's going to be the hardest job that you ever get. Every other job will be way easier after that. But in terms of like getting that first job, like I think if you can find ways to stand out, If you write a really high quality Twitter thread like that, like I'm happy to retweet you. I think she got some really, really high profile people to retweet her. And then she messaged me a few weeks ago being like, I got a job in the language I wanted, in the space that I wanted. And I was like, I checked out the company that she landed. I was like, oh, I'm kind of jealous. Like that looks like a pretty sweet job. So don't underestimate the power of social media when done correctly, when done right and in moderation. I think I kind of like went off went overboard on that one, but I hope that helps. Oh boy, so many so many questions. Oh, my Twitter handle is DeniseU21. I think that's come up. I put it in chat.
And we'll make sure to share that after the course on the email as well.
Yeah, but I'm like literally always happy to retweet like requests for help, for like looking for your first job, anything like that. I feel like that's kind of the least that you can do when you've been in industry for a couple of years. Okay, so Jonathan asked a really interesting question. Is there any kind of mental framework you and your team use to implement features that can have a great impact on the community? I love that you're already thinking about that, because I think this question is what I would consider like evidence of being product minded. And I think that is such an under-indexed skill for software engineers. So types of mental frameworks, that kind of varies a little bit based on the exact product that I'm working on. But I always try to think about who the end user is. Like I ask a lot of questions about who is our customer? How familiar are they with GitHub? Are they sort of like power users that have been around for ages and they're familiar with the command line and we can kind of like throw anything at them and they'll figure it out? Or are they newcomers or people who are less technical who have to use GitHub because everything else for their company is on GitHub? Those are two very different profiles of users, and you have to think a lot about the level of communication and sometimes even things like if you're going to build, say that you're going to build like a user settings page. There's a difference between building a settings page that has 5 options that they have to set versus like 25 options. Like one of those two is going to result in a much higher learning curve, and for some profiles of users, that learning curve is high enough that they're just not going to do it. So really trying to understand who your customer is and what they're trying to achieve, I think is the key thing. Because I worked on community and safety for a little while, I also like to try to poke holes and think of security vectors and abuse vectors. I think information security and cybersecurity is always a good thing to think about, but I don't expect like software engineers to have like extreme fluency in that, because like security engineering is a separate discipline, and those are probably experts that we rely on. But in terms of like abuse vectors, I do like to think if we build any kind of user input, any text field that you build that provides user input, I just assume that someone is going to put a bad picture in there. Like assume that somebody will upload something that's inappropriate or like in violation of a code of conduct somewhere. So given that that's true, how can you build safeguards into that? Like maybe you can build in moderation, maybe you can build in like, if it's like a really high profile platform, like if someone posts something, it's going to be blasted out to their entire organization or like all of github.com. Think about, like introducing a middle layer where some content has to be approved by moderators or something like that. So that's like pretty GitHub specific, but I hope just trying to be user centric is the thing that I learned a few years ago at a different job. And that's the thing that I still carry with me. And I still try to ask a lot of like borderline annoying questions to like my team, like who are we actually building for? Like, I think if you talk to my team, they'll probably be like, yeah, Denise is always like demanding who our end users are to the point where we're like annoyed about that. John, are there any questions on here that you think that stand out to you? There's just so many coming in.
Take a look.
There's one about the interview process, which I can answer pretty quickly. This is asked by anonymous attendee, so sorry, I don't know your name. How is the interview process for me at GitHub? I had fun during the interview process. I thought GitHub was pretty straightforward. At the time, so the interview process changes a lot depending on the team that you're interviewing for. And I think it's gone through a couple of iterations over the last year. So it's been like a year and a half since I've been through it. But from what I remember, it was just a take home that checked whether I knew how to do Ruby on Rails. The take home was actually a hard time box at 4 hours. So if I didn't whatever I had at 4 hours, I had to submit. And then it was a couple of face-to-face, well, like Zoom face-to-face, 30-minute conversations with the person who would have been my manager had I stayed on, the community and safety continued to exist. I spoke with an engineering director, and I think the only other round was the diversity and inclusion. So I think it was about 2 hours of 30-minute blocks where it's like kind of like behavioral and I don't want to say soft interview because I hate that term, but like behavioral interviews where they ask about like your leadership skills, questions like if you are reviewing your coworker's code and you see like there are 20 different things that you want to point out or ask them to change, how would you deal with that? So it was like testing your aptitude and like your teamwork skills, your collaboration skills. Yeah, I mean, like I had a pretty reasonable time with the GitHub interview. I didn't feel like it was as time consuming as some other companies that I've interviewed for in the past.
Yeah, there are changes coming to it, but I do feel like our interview process compared to most companies is like fairly light. Mm-hmm. Like by the time that you've reached that interview process, hopefully we know a lot about you technically. Exactly. We know that you've passed the general screener, and now it's really just about like, how do we imagine working with you? What do we do after this?
Yeah, exactly. Do we have time for a couple more questions?
Sure, yeah.
Okay, cool. So Manon asked, really appreciate that you switched from econ to CS. Any suggestions on how to market yourself to potential employers with limited work experience? Also, great question. I get this question a lot from people who are going through like the bootcamp that I went through. So there's another question here actually related to how I got my first job out of bootcamp. So I'll kind of answer both at the same time. The first job that I got after bootcamp was a software development role at an educational technology startup in London. And the reason why they picked up my CV, like out of the pile of other CVs, also from junior developers, including some with formal computer science backgrounds. The reason why my CV got picked up is because I actually had a lot of teaching experience. So because the role was to, write programming, to like write software that teachers and students use for remote math education, for math learning. And so because I kind of already knew the domain, or I had different work experience that was not like related to software engineering, but it was related to education, my application stood out. So my advice there is to just really emphasize if you have previous work experience, you would be surprised at how transferable the skills that you pick up in non-technical roles are for software engineering. And the best example that I give over and over again is if you've ever worked in hospitality or retail or any kind of customer service role, there are so many skills that you already have that are going to make you a better engineer than the people that are straight out of, no offense to computer science programs, but the people that are straight out of computer science programs. And the reason why is because the thing that makes you a good like all the knowledge, like data structures and algorithms and things like that, you will eventually learn that on the job. Like that's knowledge that can be acquired. But the real world skills of understanding like how to say no to someone without making them really angry at you, or like understanding how to communicate effectively with people that like expect really tight deadlines or unrealistic goals or whatever it is, like that's a skill that you can't learn in the classroom. So I would like really, really try to emphasize those other competencies you have and try to emphasize like, this is what I can bring to the team on day one. A lot of software teams are composed of people who just want to go in their own directions. And that's not actually a great way to work. So if you have experience like building a team or working together on, I don't know, like a political campaign or a volunteering organization or anything like that, the ability to take a lot of people with different ideas and strong opinions and convince them that we have to focus on doing this one thing, and this is how we're all going to contribute towards that vision. I think that is a skill that you honestly like cannot put a price on. And I think that's one of the core competencies that GitHub looks at when like we look to promote people from I don't even know what the level is like, but the level below senior into senior developer is like, can you create clarity where there's chaos? And I think that a lot of people coming in from non-traditional backgrounds already have that skill set.
That's a really good point. That like as you go higher in engineering, you would think that it's more like you're a better and better engineer, but actually the way that it normally works is that you're like a better and better team member. You're a better and better person to work with. You can communicate more clearly. That's what separates high functioning engineers from maybe not, or more junior engineers.
Yeah, exactly.
Cool. Well, Denise, if you have any resources that I can link out to people after the course today, if you can just send them to me, I'll make sure they get passed on. And if everyone can just thank Denise again for coming here. Thank you so much for being here.
Yeah,
And
for sure.
for just like everything over the past year too. It's been
I'm happy to help.
A wild ride.
It has been. There's more wild ride ahead.
Yeah.
Yeah, cool. It was nice to meet all of you, and good luck with the course.
Thank you. Don't know how to manage Zoom. I'm gonna figure it out.
I'll just leave so you don't have to email me.
Okay. Thank you. Okay, everyone. We're back. We're back to our normal session here. I hope you all enjoyed your time with Denise. If you did, please drop her a message on Twitter. So again, her handle is DeniseU21, Denise YU21. Yeah, Denise is awesome. She's really nice. There are indeed a lot of really nice people at the company. We'll have more of them throughout the time here. Not all of the presenters are going to be from GitHub, but she's great. Super happy to have her. Okay, shall we talk about the homework and talk about yesterday? I'm going to, just for my own clarity, I'm going to dismiss the questions. So I don't even know how to do that, but I don't know how to do that. So I don't know how. So it's going to take a while. I don't know if people are able to dismiss their own questions, but I don't know how to do this, so I'll leave them where they are. Don't know what else to say. Okay, here we go. I'm going to start by going through a couple of things before I even start reviewing the homework. And these are kind of like logistical type things, so just bear with me here. So I don't know how to mark all as answered. Probably it's too complicated. It's too complicated. Actually, what I'll do is, no, I'll just leave it. Well, I'm gonna want it. I don't know. I'll figure it out at some point. Okay, so the first thing is, we noticed a lot yesterday, and I got some feedback from people that there are people that know more Ruby than other people in the class. So while it's great that you know more, we need to make sure that in our discussions that we are keeping things on track. So we need to make sure that when we're talking about something, that if like there's the next topic kind of just out of reach, and you have a question about that, you can still ask me those questions. Let's just try to keep those questions either after the class or maybe on Slack. A lot of times I have a path to get to the place that I want to get to. There are certain things that I want to make sure that I talk about. And if we go away for a bit, then some people are going to get lost in kind of the minutia of the details. So just keep that in mind when you're asking questions. If the question is not about something that I'm teaching, but about some extension of the thing that I'm teaching, then please just hold off on your question. And I'm not trying to exclude you. I'm just trying to say we need to create an environment where everyone here can learn. The next thing is that part of the class is the exercises. I want to remind you of this from the first session, and that is to say that imagine you're paying for an in-person boot camp. You're paying for that boot camp, and part of what you're paying for when you pay for an in-person boot camp is actually the hours, the workshop hours, where you're sitting there actually doing the homework essentially in the class. So you're sitting there and there are people walking around and helping you. That's on you in this course because we don't have time to sit on the course for 6 hours helping with all the homework. It's really difficult to do that in a virtual setting. So that's on Slack, that's on the questions forum. But think about it when you're trying to do your homework, that if you don't do the homework, you're taking a piece of the class away from yourself that you would have if you did an in-person bootcamp. Also, just be thankful you're not paying for an in-person boot camp, because those hours that they're going to sit there in the workshop, you're paying for them. So when you're sitting there doing the exercise and you're thinking, well, no one's watching me to make sure I'm doing it, it's like the person that needs to watch you to make sure you're doing it is you. You need to watch to make sure you're doing it, because you're the only one there. I hope that makes sense too. Another thing I wanted to call out is that Julie J has organized some forum for additional support. So you can use the forum. Actually, someone just linked it in the chat, which is great. The forum is going to collect information from you about whether you're interested in a study group or office hours or pair programming. This is a great way to get some additional time that you would not be able to get otherwise. So thank you to the people that organized that, which I believe is Julie J, and now Sarah is putting it in the chat. And if I got that wrong, tell me I got it wrong, but I'm pretty sure Julie is the one that put the forum together. Although Sarah did put the Slack together, and Slack's amazing. It's like the best part of the course. So thank you for that. Another thing I want to call out is, okay, so before I did the course, I went and I talked to my wife and I was like, listen, we have a lot of people in the course. And she's like, what's a lot of people? Like 20 people, 30 people? And I was like, well, no, we have like a couple hundred people signed up. And she was like, oh my God, you have to turn off the registration because there's just too many people. You're not going to be able to do anything. So then we did a little bit of research and we did research into the average drop-off rate of online classes. And it's pretty startling because the average online class has a drop-off rate of about 90%, which means that only 10% of people that commit to taking an online course actually finish the online course. So I wanted to share a couple of quick statistics with you, or not statistics, but just numbers, which is that we started our first session with 184 people doing the synchronous course, meaning they're coming into the lecture every day. And now we're down to 124. So I'm saying this, we had 127 at some point in this lecture. So my official number is 127, but I'm saying this to encourage you that the numbers are going to go down. That doesn't mean that the thing you're doing is impossible or difficult or harder than you thought it was. Instead, what it means is that you're the one continuing to put in the work. You're the one staying with the course. So when people leave, don't think that things are going down because things are bad. Things are going down because the average course also has things go down. And to answer Kevin D's question in the chat, I don't think so. I think it's just how courses go. Like who here hasn't signed up for like a Udemy course or something and then not actually completed it to the end? So I want to just say that to make sure that all of you know that as you see the numbers drop, it really doesn't mean anything other than the fact that if you're still here, you're committed. Okay, next thing I want to talk about, and this is less housekeeping thing, more of just a normal thing, which is that I'm going to spend the first half of this class, meaning probably up until the break, and then most or half of the way through the second part of the class, talking about yesterday's homework and yesterday's content. But at the end, I am going to talk about the next piece of content, which is going to be classes, which is a very important concept in Ruby. So, let's keep it focused. Get your questions ready about loops, get your questions about functions. You can drop them in the chat now. I'm going to sit here until there basically are no questions. I'm going to try to find the best ways to explain this stuff. And yeah, that's it. Feel free to drop questions down below. And in the meantime, what I'm going to do is I'm going to bring up the homework for session 3, and I'm going to do it one at a time with you. So if questions come up as I'm going through this homework, then I'm going to answer them. Can you please go for loop and function? Yes, I will. I'm going to go over all those things. Yeah, that's a great point, Kevin, is that in a large part, the people in the class are the support system for each other. Just like Denise was saying when she was here before, that her class really stuck together and supported each other. I see you all doing the same thing. I see the chats. I see some more senior engineers or senior engineers, same level as me, that are in the chat talking to you all. They're doing that to help you, and it's really kind of them. So thank you. Okay, let's go. Okay, I assume now that everyone is seeing the right thing. This is the exercises from yesterday. I'm going to start with exercise 1. So I'll start by copying it over. I'm going to bring it into here. I open my main.rb. I'm going to drop it in here, and then I'll use the handy thing we learned yesterday, which is command/ just to comment it so I can see it while I'm doing it. Okay, let's start out. We're going to start with an array of 5 names. John, Kate, Abby, shout out Abby. She's on the course somewhere. Hi, Abby. Sabrina and Jimmy. Okay, go through each of the names. So when you read go through each of the names, the initial thing that you have to think in your head is what? What is, when you want to go through each of something? Each. Yeah, a loop. I mean, either of these is correct. The answer is that when you want to go through each of something, there's a method for doing that called each. And this is what it looks like. So just to break down the parts of this, you have the name of the thing that you want to go over. Then you have the method name, which is always each. Remember, each is the one that goes through each thing in the array. So each thing. And then what will happen is we're going to write something in here. And when we write something in here, each time that we go through it, we'll call it name. So we'll execute the same thing over and over again, but call it name. So that's this line, go through each of the names. That's basically how you can read this. Go through each of the names, right? Think about how it's going to work. This is how I want you to think about it. I want you to think there's an array. It's got Kate. It's got John. It's got Abigail. And here's what I want you to think when you think of each, okay? I want you to think like this. First, it's going to run like that. Then it's going to run like that. Then it's going to run like that. So first, name refers to Kate. Then name refers to John. Then name refers to Abigail. This is what an each does. Name, name, name. All in order, okay? So to answer the question here, this does not have to be called array. And this does not have to be called name. So in this case, it's the name of the variable. So I can call it names if I want. Names and names.each. And this thing inside, I can call it whatever I want to. In this case, I'll call it name. So it's an array called names. I call each on it. And then each time, the element will be referred to by this name, which is name. Okay. Now, what does it say I want to do? I want to output a sentence containing the name and the length of the name. Okay, I can do that. Puts the name is name and the length is name.length. Okay, so you can see the output here is the way that I want it to be. Hopefully this line makes sense to everyone from the second session. Puts is how I output something to the screen. And then these are string interpolation. So I put something inside of there. And basically this special little symbol, start and end, tells Ruby to take the part inside of it and evaluate it to see what it means. So rather than write the word name into the string, it will take the name and put it in here. So this name and this name are the same thing. So we can prove that to you by saying something like rename it to person. And then if I put person here and person here, see that these three person references are about the same thing. Okay. Now I've done something, but cool. Okay. If the name has an even number of letters, capitalize the name. Now we know that we have an if. And an if lets us do one thing in case something's true. I got the error because I didn't save the file. So if person dot length dot even. Okay. Yeah, we're not covering push, but I will talk about the pluses in a second if people are interested in why the pluses won't work. So it says here that it wants to output a sentence containing the name if it has an odd, even number of letters, capitalize the name. So what I'm going to do is I'm going to copy the same statement into both of these. And then if it has an even number of letters, I'll capitalize the name. So now you can see that John, Kate, and Abby are capitalized. Sabrina and Jimmy are not. Okay, so a question that I see down here is why can you not use plus? So imagine I tried to change this to this. And the length is plus person dot length. Okay, so this is the code that I'm imagining people are talking about. And if I run it, you're going to see this error. And it says, no implicit conversion of integer to string. And I'm going to help you think about why. So let's just think about what this is doing. So it's saying, I want to take a string and another string and another string and an integer, or sorry, a number, and add them together. And what I would propose back to you is, what is the answer of John plus 5? There's no automatic type conversion. John plus 5 is an error because you can't add a number to a word. They're two different things. So if you take a number and a word and you try to add them together, it's not going to work. So if you're interested in doing that this way, what you can do is you can convert the number into a string by using a method called toS. So what that's going to do is going to convert the number to a string. Okay. So just think when you're getting an error about an implicit type conversion, it's normally because you're trying to do an operation like add two things together, but the two things are not the same type of thing. It's like trying to add like apple plus orange. Just because they're not the same. So in order to add them together, you have to convert one. And this is a great reason why it's easier normally to use interpolation, because what interpolation does is it actually, you can imagine, converts everything to a string. So when you use interpolation, you don't have to think about what the types of the things are. They just get automatically converted. Okay. So if you're doing something where you can use interpolation, normally in Ruby, you'll use the interpolation. So if I wanted to make it work without it, I could change just the toS, run it, and it works just like it did before. Carmen, I'm going to hold off on that question. I hope you don't mind. But I do, yes. I'm going to show you If you're wondering like what if we modified this code in some way and did something else, what I would say is like try it in your editor and try it and see what happens. And that exploration is going to bring you in a bunch of new and fun directions. It's going to teach you something. Okay, I'm going to go through how to add this in GitHub just because I've heard so many people wondering how to do that. So we have to cover it. So you're going to want to go to this one over here, which is the little symbol of two paths going off, and then a 1 or whatever number it is. When you get in here, you'll click this plus. Okay, and then once you've clicked the plus, I want you to click the check. Now you're going to type a message of what you're doing. Just trying out some Ruby. Hit enter. Now, in order to do it, you're going to need to push. And for that, you'll click these 3 dots and click push. Once you do that, it'll make its way over to GitHub. Sure, you can use the terminal if you want to. Can show how to push. Okay, next question. For exercise 1 of the capitalize the name, does the if else only work when you put names.each do person only? No. Because I tried name. Yes, you can do that, except the code that you wrote there is not going to capitalize the name. So, but I get what you're saying. No, you don't need to make a pull request. Okay. Yuri, if you can bring that chat into Slack, we should be able to help you more, and then we won't take away class time doing it. But I appreciate that you want to know because you'll want that in order to send the homework over. Okay, I'm going to go to the next exercise question. Is there any more questions about this piece that are relevant to, I guess, what we've learned so far? And I promise again, I'm not trying to sass anybody. I'm just trying to make sure that there's room for everyone. Cool. Okay, here we go. We're going to create a function that takes in a name and number, and the function should output the name the right number of times. So we need a name for this. I'll call it puts name times. I don't know. It takes in a name and it takes in a number. So this is the basic structure of a function. We have the word def, and it will always be the word def. Def, I want you to think of it as define. That's what it means. Def, define. You're always going to have the word end. And that's going to define some kind of a block. And then inside the block here, inside of this between the def and the end, we can put the things that the function should do. Other parts of the function are the name of the function, in this case, puts name times. And then the 2 arguments names here are name and number. And the way that we use the function is the same way that we used all the other functions we've learned so far. We pass it a name and we pass it a number. So when this gets called, name is going to equal John, the string, and number will equal 5. I'll prove that to you right now. So puts name, actually I'll do puts name is name, puts number is number. Let's save that and let's run. So yeah, name is John and number is 5. So now what we need to do here is that we're supposed to output the name the right number of times. Okay, so how do we output something a certain number of times? How do we do anything a certain number of times? You can use each, you can use a loop. The easiest way is with times. So remember yesterday we learned that there's a method called times that you can call on any number type. And it will take a do end, and it will do the inside of here however many times you tell it to. So if I put in here, I write puts, did it, and I run this, you're going to see that the output, if we can figure out, is did it run 5 times. So all it does is it takes however many times you want to do something, and then does the inside of here that number of times. Now, of course, the assignment is not to output the words did it. The output, the name is what we want to do. So we'll change this line to output name. Let's run it again. And now we've done the assignment. We're doing John 5 times. Is this making more sense? And if you remember yesterday, we're allowed to write our blocks like this. So if I run this, it does the exact same thing. Okay, so just to really drive that home, 5.times do something, and 5.times that with something in here, if you were able to do it. These are the same. These are the same thing. They mean the exact same thing. Sharon will cover returns in a second. And yeah, okay, that's good. Great question. I think your name is Abdukhalil. I'm going to go with that. I think that's right. If not, let me know. But I tried. I just don't know how to say a lot of the names. So Abdu. So Abdu, the reason that it comes after is because first we're defining the function, and then we're using the function or calling it. So you can think of this as like a recipe, right? This is how to do a thing. And then this is saying, oh, actually just go do it now. So you can actually imagine if we called that twice, I'm going to save it again. Now it's going to output it 10 times. And it's because the first 5 times are the first time it called it. And the second 5 times are the second time it called it. And I can actually change these things. I can make it Kate 3. Run it again. Now I've got 5 Johns, 3 Kates. So again, this is defining the method. And these are calling the method. If I don't put these 2 lines, imagine I commented them both out and I ran it. It's not going to do anything. Does that clear it up? Someone asks, Carmen asks, can you put Kate and 3 in a variable and call the method using that variable? Yeah, I think that is a good idea and on topic. So if I made a variable called John and I had a number, I had a variable called age equals 10. These don't have to just be passed directly here. They could just say name and age. So in this case, like this doesn't have to be a string. It can be a variable that points to a string. So if I run that, you'll see I've outputted John 10 times and Kate 3 times. Sarah says, when I did this, it would print the number after the name X times. I added puts at the end to stop it, but I'm not sure why it did that. I'm guessing what happened is that you had actually a puts down here. Okay, so if I, if I run that, see that? And the reason it's doing that is because number.times returns number. So the way that your instruction is working is it's saying, oh, hey, output the thing. And then when you're done, output the return value of that function, which in this case is number. Kevin asks, will a function always have 2 arguments? No, a function can have any number of arguments. So what we saw yesterday is that there might be a function called print hello, and that function has no arguments, 0 arguments, nothing after it. You can even, if you want, you can do that, although it's not very normal to do this in Ruby. So this is a function with no arguments. You can have a 1-arg function. That's okay. You can have as many as you want. Reso, yes, of course. You can pass a hash as an argument to a function. You can pass anything as an argument to a function. Ernest says, I thought that puts always returns nil. How come we had 10 as the return? I will tell you why, because remember we were talking about yesterday that you can think of an implicit return as being this. So the thing that's actually being returned, the last statement in here, is not the puts. It's actually number.times. And the times method, returns the number itself. Mine has this message when I try to push. Can't push refs. Okay, Yuri, you just have to go in the Slack chat and people will help. Okay, I can't help here, unfortunately. I want you to be helped, but I just can't do it here. Okay, I'm going to go to the next exercise. If you're submitting questions that are jumping ahead for now, I'm going to mark them as complete, but please hold them to the end, and I can try to spend some time talking about them. Okay, so here we're going to write a function that returns the largest number in a given array. So we'll call it largest number, and it takes in an array. So this is a function called largest number that takes in an array. Okay, let's call it. We want take in an array, return the largest number. So let's put largest number of, let's call it numbers. And let's make an array called numbers that contains 1, 5, 3, 8. Okay. And now I'm going to run this. So it outputs nothing. The reason it outputs nothing is that this method doesn't do anything yet. So you can think of it basically just does this because there's implicit return. So it returns nil, returns nothing. And there's a really easy way to write this, which is array.max. So I've done the exercise now. I've written a largest number method that takes in an array and returns the biggest thing in the array. But then there was this bonus question of now try to do the same without using max. Okay, let's think about how max works. Actually think about if you were a person and someone handed you a bunch of index cards. Okay, and they handed you the index cards and they said, okay, here's a number 3, Here's a number 5. Here's a number 7. Here's a number 2. How would a person sort these? So here's how you would sort them. I'm going to tell you, because it might not be super intuitive, that this is how you would do it, but I promise you, this is how you sort things if you have them as cards. You'll start by looking at the first thing. You'll say, wow. You'll start by looking at, why is it doing this? You'll start by looking at the first thing. And the first thing, oh God, no. This is ridiculous. Okay. I apparently can't move them. Okay, you'll start by looking at the first thing. The first thing is 3. And you'll say, okay, the biggest thing I've seen so far is 3. So you'll remember, okay, 3 is the biggest thing I've seen. No, down arrow is not working. It's broken. Everything's broken. This is my favorite thing too. Anyway, I think what I'll do. Okay. The biggest thing I've seen is 3, right? So I'm going to put 3 over here. Then you're going to look at the next thing. You're going to say, okay, now I'm looking at 5. Okay. And you're going to say, is 5 bigger than 3? Well, of course, 5 is bigger than 3. So you're going to change the thing that you now think is the biggest thing. You're going to say, the biggest thing I've ever seen now is 5. Okay. Then you look at the next thing, 7. 7 bigger than 5? Yes. So you'll update your thing again and you'll say, okay, now the biggest thing I've seen is 7. Then you'll look at the last one, it's 2. You'll say, is 2 bigger than 7? And it's not. So you don't update your thing. So then you, as a human looking at these cards, have deduced that 7 is the biggest thing you've seen. I hope this makes sense to everyone, because this is how you actually do it. Meaning, like, if I handed you a stack of cards and you can't look at all of them, this is the only way that you can figure out what the biggest one is. You have to just go through each of them and figure out if it's bigger than what you currently consider to be the biggest thing. So let's try to tell the computer to do that exact same thing. Okay, so the first thing is we're going to create a variable and we're going to call it largest. Okay, now think in here when we're doing this, when we're doing largest, before I look at 3, what's my current largest thing? There is none. I have no largest thing. So there's 2 potential answers you could get here. You could either say the answer is nil, because before I look at 3, I haven't seen anything big. The next answer is you could say 0. Now, there's a problem with 0. You can probably imagine the problem with 0 is that if one of these numbers was negative, when you get to it, you're going to think that 0 is bigger. So you'll give out the wrong answer. You'll say that something is bigger, even though there is not even a card for it. Okay, so the best way is to say nil. Okay, so that's what we're going to do in our code. And now you're probably seeing what the value of nil, like why you need nil. So we're going to start by saying, okay, the largest thing I've seen so far is nil. Then what did we do in the example after that? We went through each of the cards, remember? And for each of the cards, so this is how we go through each of the cards. We use each. Whenever you hear someone say, go through each, that's what it is. We're going to go through each. We're going to take an array, dot each. And now what we have to do in here is we have to say if the number is greater than the largest number I've seen, then set the largest number equal to the greatest number I've seen. Okay. So this is the same thing that we were doing over here. Go through each element, each card, and you say if the number on this card is bigger than the largest thing I've seen, then set the new largest thing I've seen to be that number. Okay. And then when I return out of this method, the last thing I want to do is I want to return largest. Okay, so I'm going to run this, and the result may surprise some people. Okay, so the error here is that you can't compare an integer with nil. So what does that mean? Can't compare an integer with nil. Where are we comparing an integer with nil? Yeah, in the beginning. So you imagine we set our biggest thing to nil. When we look at our first card, this is a part that I didn't talk about when I talked about how a human has to do it, because you just like intuitively do it. Someone hands you a stack of cards and you just like do the thing that makes sense, right? But listen to what you have to actually do. And it's kind of amazing that humans are able to just do it. The thing that happens is when you first look at 3, you're doing something slightly different. You're not saying, is 3 bigger than the biggest thing I've seen? You're saying, de facto, I haven't seen anything yet. So 3 is, of course, the biggest thing I've seen because I've seen nothing. Okay. There's a couple ways to solve this. I'm going to show you a couple ways to solve this. So the most straightforward way to solve this is when you're checking, you want to say, if largest is nil or, okay? So what this means is that if largest is empty, or the number is bigger than largest. So this is the thing that we were just doing in the card. In the first case, you're saying, is largest empty? And in every case after that, you're saying, is largest, is the card bigger than largest? So let's run that. Okay. There's actually a even sneakier way to do it though. And some of you may have come up with this. I'm going to take this part away. And instead what I'm going to do is I'm going to set largest to array.first. Okay, I'm going to run it again and it still works. So why does that work? Yeah, sorry. I didn't teach first yet, but that's the same as writing array of 0. So why does that work? Why does array of 0 work? Think back to the cards. It's a slightly different tactic. Instead of saying, I haven't seen anything yet, so my current understanding of what's biggest is nil. Instead of doing that, you say, okay, I'm just going to look at the first card and assume that it's the biggest thing I've ever seen. That's what we're doing with this. We're saying, hey, before you know anything about the world, just assume that like the biggest thing you've ever seen is the first thing you see. Then go through all of them. Then return the value. This is the answer. This is how you do it. Like people are mentioning in the chat, you can't have this be 0 because if you did, then it couldn't handle anything about negative numbers. But if you knew that your array did not have negative numbers, then you can do that. You can do the 0. Yeah. Someone asks, what's the largest on line 18 doing? Remember, Ruby has implicit return, so you can read this line as return largest. So all largest on line 18 is doing is returning the value. Cool. Okay, so someone mentions in the chat another kind of interesting idea. I'm going to say it just because I think it's interesting. It's built of all the things that we did already. So Another way you could implement largest number is you could do array.sort. Okay. Dot reverse of 0. So this is, again, there are shorter ways to write this, but I'm purposely showing you this way because it uses all the pieces that we've written so far. Okay, I'm going to show you how this works. Imagine these are the cards that I have. Okay, so what it's doing is it's saying, okay, first sort them. So put the 2 at the top, 3, the 5, the 7. Then reverse that sort. So put the 7 at the top, then the 5, then the 3, then the 2. Then it says, grab the first one. That's the biggest one. And my response is, yes, this works. And it's actually, it's a fun answer. But what I challenge you to think about is it simpler? And without knowing anything about what's simpler or harder for a computer to do, the way I want you to think about what's simpler is think, if I was doing that with physical cards, is that actually faster? Okay. And the answer is that it's not. The reason that it's not is because in order to find the biggest one, you don't have to go through the process of sorting. Imagine you had 100 cards and you wanted to find the biggest one. The fastest way to find the biggest one is just to look at every card and do the comparisons that we were doing. Now, imagine someone sat down next to you trying to find the biggest card, and the first thing they did is they're like, well, I want to find the biggest card. So what I'm going to do is I'm going to put all the cards in order first. That's the equivalent of the other operation. And while it still works, it's slower. Is that clear to everyone? That's what I'm saying, is that for the most part, the computer has to do what you have to do, and that the simpler thing is the faster thing. Okay. Now we go to the big boy. Okay, we're going to write a function that takes in an array of names or whatever and puts them out inside of a box. Okay, I'm going to show you a normal way to do this that I would expect you to do given the tools that we have so far. And then I'm going to show you how to write it a little bit nicer. I'm not going to teach you anything new to show you how to write it nicer. I'm just going to show you the naive way to write it and then just a little bit better. So let's make that variable called names. I think I used John, Kate, Jimmy. It's actually funny. The reason that I picked these names in this example, the reason that Jimmy's here is because it is longer than the other two. But actually the reason that I picked these two is because they are the same length. So there's kind of an interesting thing there is like by choosing these names, I'm also testing the edge case of what if two things are the same. I know Julian's got to be in here. Okay, so the first thing is I want to print out a bunch of stars. So let's say to print out a bunch of stars, I want to print star. Let's say I want to print as many stars as I need. So I could do this. I could do 3 prints in a row, but we have times, right? We have times. So I know if I knew how long the longest name was, then I could know how many stars I needed to put out. In particular, the number of stars that I would need to put out is however long the longest name is, plus 4. So any wondering why plus 4 is because I need to have 2 stars for over here and 2 stars for over here. That's the only way that I'm going to get the top line to be long enough. I have to account for the spacing on the 2 sides of the longest name. Okay. So let's start by saying, how long is the longest name? We'll make a variable called longest name length. Okay. You do names map. Actually, let's put this in a variable. Let's call this just longest name. A lot of times it's helpful to do things one step at a time so that you can see what happens. So let's output that. What have I done? Sorry, this is called name lengths. Okay, so again, map takes in one array. It's called on one array. And then it executes the inside of the curly braces or block one time for every element in the array. And then it outputs a new array with those values. So remember the diagram that I drew yesterday? I did something like this. Remember, I took this, which is your map logic. And imagine your map logic said times 2. The map takes the first array that you put in and it outputs an array where each of those values has been mapped into a new value. So it returns a new array where you get 6 and 4. This makes sense for map. A map takes in one array and then does something to all the things inside of it and returns a new array. Okay. So in this case, what I've done is I've taken all the names and I've mapped them so that each one gives the length. And now I have an array of lengths. Actually, if I call inspect on that, you can even get a better look at what it is. It's an array. It's an array where it's 4, 6, 4, 5, because John has 4, Julian has 6, Kate has 4, Jimmy has 5. Okay, now back to what we needed. We needed the longest name length. Now, what's the longest name length? Well, we learned that we have name lengths dot max. Okay, so now I'm going to output that. Puts longest name length 6. So now we know how long the longest name is. Now let's make a variable called top bottom star count. And like I said before, that's going to be equal to the longest name length plus 4. Or if it's easier for you to think about it, it's 2 plus the longest name length plus 2. Because it's a star and a space at the beginning and a space and a star at the end. Okay. Now with that, what we can do is we can we can do top bottom star count dot times, and we can print a star. Oh, look, we got stars. And just to verify, we have the 2 starting stars. Then we have J, U, L, I, A, N, and then 2 ending stars. So we'll just write that that's the top line. Now, you probably all understand that the top line and the bottom line, they're the same. So let's just do that right now. Just copy this and change it to bottom line. So now we've got 2 pieces of our puzzle all figured out. I'm going to remove the other outputs. So if I run this, now I've got 2. And uh-oh, what happened? Exactly. There's no new line because print, remember, does not put you can think of it like a typewriter when you hit the enter key and it goes to the next line. Print does not do that. So we have to follow each of these with the puts. Run it again, and now we have what we want. It's the top and bottom of our box. Okay, so now we want to go through each name. How do we go through each name? Well, names.each to name. This is our iteration over the names array, calling the thing name each time. Now, I know I don't want to run into the same issue I ran into before with the puts. So I'm going to start with the puts. And what happens at the beginning of the line? I have to print star space. And I know that at the end of the line, I have to print space star. And I know that between them, I have to print the name. Let's run that. Okay. I don't know, we're getting there, we're getting there. There's one piece of the problem left is this part here. So I'm going to copy this just so we can read it together. It says, how can I make the box stay consistent with despite the names having different lengths? Yeah, so ideally we want this star to line up with this star. Okay, so we need some kind of way to do some type of padding in here, some extra spaces, right? So we know that we want to put in extra spaces. And now the question is how many extra spaces? So let's make a variable. Let's call it extra spaces. And for now, let's just set it to 5. How can we put extra spaces in here? Well, we know how to do that. We know that part of the problem. It's extra spaces that times print space. I run that, you'll see I've done this. So now the only thing left to solve is that instead of extra spaces always being 5, I have to figure out what extra spaces is myself. Okay. So for this, I'm going to do another quick drawing. Imagine you had this. You had J, O, H, N. And then there was someone else called Joe. And you wanted to make John and Joe have the same number of spaces. You wanted to pad them out the right number. How would you do that? How do you figure out how many there are? The answer is that the number is always going to be however many numbers, however many spaces there would be extra in order to make Joe and John have the same length. So it's however long the longest one is minus however long the smaller one is. Okay. So however long the longest one is, we actually have a variable for that already, longest name length, minus however long the smaller one is, name.length. So let's run that. Sweet. Okay, because I know this confused a lot of people, I'm going to pause here for a second just to take any questions on this, and then I'll get to today's content. I would encourage anyone that didn't get to this or got to some version of this that they didn't like to give it another shot. Just try it again on your own. There are smaller ways, by the way, to write this, but this is illustrating all the concepts. And I want to really stress for everyone the point that what you need to do is get there. You need to get to the solution, meaning like you have the thing you want, you get to the solution, and then you do what programmers refer to as refactoring. So what that means is that you write something, even if it's not pretty, even if it doesn't work very well, or it's not fast, then you figure out how to make it more readable, or how to make it quicker, or how to make it better. That's what engineering is. It's like you don't just write the code and then you're done with the code. You write the code and then you refine the code, make it tighter, you make it better, you make it faster. And that's what engineering is. Okay. If you don't do that process, then that's not engineering. That's just writing code. So we're all engineers here. Can you see all the code for exercise 4? Sure. Yeah, this is my solution. Okay, I'm going to go through a couple of these questions. Manon asked the question, but I think it's from the previous topic. If you ask that again at the end, I'm happy to answer it. If I sorted array from smallest to biggest, yes, we covered that. Okay. The next question is, I keep on getting the error undefined local variable or method names. Just make sure that you've saved, which you can do via Command S. If you're using like the keyboard shortcut, sometimes you can try to run it before the editor has had a chance to save it. That's bit me a few times already. And the next question is, why does the extra spaces only print the lines that have fewer spaces and not all of them? Yep, the reason is because here we're inside of this each. So you can think inside of here is what it's going to do for one name. And because we're making this calculation of extra spaces based on the length of the individual name, when this part runs, it's just doing it for one name. So that's why it does it. Is because, and that's kind of like the power, the power of programming is like we're in here, we've written something one time, but now we can do it an infinite number of times for an infinite number of names without changing anything. Yeah, so Sarah asked the question, and the question asks for a function that takes an array. Yeah, just put it inside a box. So, box array. Take all of this, indent it, and box of names. So, same. Sorry, this is supposed to be called names. Yeah, it's good. Good question. Magana asks, why is there a puts under the last one? It is because if you run this code, and I know a couple of people ran into this in the chat, is that when you're finally done with the program, you want to make sure that the next thing that's running has been put back to the start of the next line. So it's like if you're on a typewriter or something, and you're mid line, and then you feed in a new piece of paper, but you haven't gone back to the beginning of the line again, you'll start typing in the middle of the page. So that's exactly what this is. You want to make sure you do the puts so that the next thing that types, which is not going to be this program, but maybe something else, can start on the next line. Rubina, I believe, has a background in other programming languages and asked about types. Ruby does not have them. It's not statically typed, so no, there's no way. Okay. We are going to get into some new stuff now. And hopefully it's not going to be super confusing. Also, I want to say, just while I have like a note here next to me, it says I'm going to be a little bit delayed sending out the email today because I'm going to record a podcast after this. So it'll just be a little bit later than normal. Okay. Today we're going to talk about classes. We don't have a lot of time to do it, so I'm going to start. We're not going to talk all about podcasts. We're just going to talk a little bit about we're not going to talk all about classes. We're just going to talk a little bit about classes, just enough to be able to do the exercise that I'm going to give you today. And I promise you, if you do not complete this exercise, I won't blame you, because classes are one of the most important things in Ruby. I hope you can make it through it. I want you to try your best, but don't get down on yourself if you can't do it. I would actually say it's probably more important to go do last week's one on your own than it is to do this one. But let's get started. I said at the beginning of the class that that Ruby was an object-oriented language. And I want to talk about what that is, especially because I know a lot of you have done programming and things like JavaScript before, and JavaScript is not an object-oriented language. So what I mean by object-oriented language is that there's a thing called a class. So I want you to think of a class as like a box that contains something. So imagine I have a class and I want to call it car. Okay. Car contains a couple of things. Car contains methods. So what can a car do is what we're talking about when we talk about a method. A car can drive. A car can stop. A car can turn. Okay. And there's also, next to those methods, potentially a list of properties. So a car has a color. A car has a number of wheels, mostly 4, but who knows? A car has a potentially driver, person that's in the car, or a number of doors, or other properties about the car. And this is what an object is. So an object, again, is a collection of things that can happen, which we're going to refer to from now on as methods. And it has properties, which we'll refer to from now on as variables. Okay. We're going to talk about, I'm going to go to code and I'm going to show you how these things work. Okay, so I'm going to tell you a couple of things first, which is when I do this string hello, you may have heard me say a few times that what I'm actually doing here is I'm making an object, and that object is of class string. And remember, we went and looked at the documentation. And in the documentation, it says a string object. Okay, so what does a string have? It has these methods, things it can do. It can capitalize itself. It can delete characters from itself. It can go through each of the characters. These are things that a string knows how to do. And it has attributes, except in the case of a string, the attributes is just the string itself. So, or the characters that are in the string. So what I want to do is I want to create a class. And the way that you do that is you go like this, class car. Okay. I'll talk about objects in a second. I'm going to skip that for now, though. So, okay, so when you create a class, what you're doing is you're creating the outline of what class is. You're defining the behavior of a car. Think about that, defining the behavior and attributes of a car. Classes in Ruby typically get a capital first name, and that's how you're going to typically separate them from other things. Okay, classes get capital first name, And if they're multiple words, they get capitalized every word. Okay. Now, the other thing about classes is that we're creating the definition of what a class is, meaning this is the behavior that wraps up a class. And I want you to think of that as this is describing how cars work. But describing how cars work is different than describing a particular car. Okay, so this is how cars work. And in order to make a car, say like John's car, Abby's car, these are the cars over here. And when we talk about them, we say that John's car is an instance of car. It's like it is one of all of the cars in the world. Okay. This is called a class. And this is called an instance, otherwise referred to as an object. This is how I talk about a car and how it behaves. These are actual cars. So the parallel in strings is like the class string that is talking about how strings behave. This is an instance of string. So string is talking about how strings behave. The string hello is an actual string. Okay, so the way that we make an actual car is called car.new. Defining the behavior of a car, creating a car. I want you to, like, it's like a factory, right? It's like, here's what a car means. Here I'm creating a car. And I can create multiple cars, just like in the previous one. I can make Abby's car. Abby, you're welcome. I got you a car. Okay. So now we have the definition of cars, and we have two instances of car. Does this make sense to everyone? You need this. Okay, now check this out, because this is the best part. Okay. I've created the definition of how a car works. I've created a method inside of car called drive. Then I've created a car. And then I've called the drive method on it. Just like we've been calling hello.reverse, where we've done like name equals hello, name.reverse. This is the same thing. So the same way that like there are these pre-existing classes like string or array or hash, we've now made our own class, but our class is called car. And yes, new is universal for all classes. You don't have to define it. So new is something you get when you create a class. You get access to be able to create new instances of the thing. That's just something that happens when you create a class. So just really drive it home one more time. Drive it home. You have a car that has a method that knows how to drive. You're creating a car. You're driving that car. So this is driving one instance of the car. Okay. This is the most powerful part of the language, any object-oriented language. It's the most important thing. It's the thing that everything depends on. Drive it home. Okay, so I can put different methods in the class. Let's go look at this actually. I've got drive, I've got stop, and I've got turn. let's go make those. Drive, stop, puts stopping, def turn, puts turning. I can do whatever I want with my class. I can drive it. I can stop it. Driving, stopping. The object is John's car. The way that you would say it is John's car is an instance of the class car. Yeah, drive here is a method inside of car. So it's a method only available to cars. Okay, so for example, string has a method called capitalize. Remember that? But you can't do array.capitalize. It doesn't make any sense because capitalize is a method defined on string, not on array. So it's a method that's only available to things of the type that it's defined on. So in this case, these methods are only available to car. We created the method. We created the method drive on car. And then we went and used it. You got it, for sure. Class is not like the dealership. Class is like, I guess, the blueprint. Yeah, the blueprint is probably the best way to say it. Class is the blueprint for how the car works. And then a car is like your physical car, you know, or class is a diagram or a recipe or any of those terms. It's a, here's the description of what it means to be a car. And then John's car is like an actual car, you know? So you have the description of what a car means, actual car. Okay. Now, and we're going to use always with this, like snake casing is called, with this underscores in between. That's how we name objects. And the way that we name classes is with the capital first letter. On line 18, do you always need new? Yeah, you do. Because if you didn't have the new, then what you're saying here is you're saying John's car is equal to the definition of what a car is. Right? Remember, that's what this means. Definition of what a car is. Saying John's car is equal to the definition of what a car is. That doesn't really make any sense. It wouldn't work. We can actually even try to run it and you'll see what happens. It says undefined method drive for car class. So it's saying there is no method drive on the definition of what a car is, right? When you see car class, definition of what a car is. It's only with the new that you're making an actual car. Class and object are not the same thing. Again, like the class is the definition of what it is, and the object is the individual one of them. And these methods are just like all the methods that we drive before. So imagine a method wanted to take in an argument. So we can do the same stuff that we wanted, driving speed. Okay. We are not calling it, so let's say you want to say 65. Okay. There's so much more. Get ready, it's gonna be awesome. There's a special syntax that you can use inside of these methods. You can say at speed equals speed. Or let's say at current speed equals speed. Okay. So you know how we've been defining variables this whole time? This at sign means that you wanted to find a variable on the car itself. Okay, so this is when we were talking about here, we're talking about color, number of wheels, driver. Those are these things. Anything with an @ sign is saying, oh, for this car, I want to set the current speed to this, okay? And then what I can do, I can say stopping from current speed. Let's run that. It is somewhat like this, but it is not like this. And I'm not going to talk about why because it's confusing. Okay, so here in Drive, I'm setting a variable on the instance, which from now on I will refer to as an instance variable. You think about it, it's a variable on the instance. When I talk about a variable like this that is not on an instance, we're going to call that a local variable. So this is a local variable because it's not on anything. It's local to wherever you are, meaning like you can only call it, you can only talk about it down here. It wouldn't make sense to try to talk about it up here. And anything with an @ sign is called an instance variable, right? So what this is saying is when Drive gets called with a certain speed, I want you to remember the speed. Take the speed and record it into an instance variable called current speed. So now the car knows that it's going a certain speed. And once you've defined that instance variable, you can use it other places. So you can see down here, even though down here, we don't know anything about current speed, we're actually able to access it because inside the class, we have access to all of the instance variables. Drive sets the speed, and stop says stopping from current speed. And this is the point where I want you all just like pause for a second and just think about just how cool this is. I mean, it's just so cool. And it's cool because the class now is in charge of everything about itself. It's in charge of how it behaves, but it also can have state. It can hold on to something that it knows about itself. So it's able to hold on to the current speed and remember it between calls. We're encapsulating the entire behavior of what a car means. So we can even do something here like when you stop, what is your current speed is going to turn to 0, right? So now if your current speed is turned to 0, now what I'm doing is I'm saying when you stop, set the current speed to 0. So now the car knows at any given time knows how fast it's going. Yeah, good question. So the question is, can you access the instance variables from outside of the class? Let's give it a shot. So it puts John's car at current speed. Let's run it. Okay, look, undefined method current speed. So this will answer your question. You can't do it. You can't access current speed from outside the class. So if you want to, let's do it. Just def current speed. And what's the definition of current speed? Well, it's return at current speed. And because there are implicit returns in Ruby, it's just this, just at current speed. Okay, so let's run it. Driving 65, stopping from 65, then my speed is 0. It's so cool. It's, it's just like, even going through this, it makes you kind of just sit back and it makes me at least appreciate that someone thought of this idea. Someone thought that objects were the best way to organize a piece of code. And they built an entire revolution of computing on this idea. modern languages, basically every programming language is based on this idea. There are a few exceptions. JavaScript is an exception, but object-oriented programming languages rule the world. Java is an object-oriented programming language. C++ is. There are so many of them. I could name them for days. It's absolutely used in developing games. It's used everywhere. It's the most important concept, arguably, in all of computer science, because it allows you to conceptualize something in the real world and easily model it in a computer. So you say, here's a car, here's a current speed. It has some kind of internal state, which is represented by these instance variables. It has methods that can do things. So it is fully responsible for itself. It's the most amazing thing. It's really, really cool. There are other ways to program, but like Eric is saying, this is the one that makes the most sense. It's the one that works with human brains, because you think that you're looking at the things around you, and objects are how we think of things. This is a glass. It's clear. It has a level of water, and it has a certain amount of water in it. You know, when I call the pour out method, the amount of water goes down, and that's what we're doing here. We're modeling real world objects, essentially defining them as a set of behaviors and properties. Okay. It's really, really cool. Yeah, some people, I think the answer is no, because there's a lot of languages in the world, but some people do think that Ruby is one of the purest object-oriented languages because everything is an object in Ruby. You'll find even nil, which in a lot of languages is not an object, in Ruby is also an object. It is a certain thing that is an instance of nil class, which is a special class only used to represent the value nil. Yeah, I can explain what the properties of our car class. When people talk about properties, they're often talking about instance variables. So the properties of our car class is the current speed. And there's one more piece I have to cover before I go through the homework today, because you're going to need it for the homework. And that is a special method called Initialize. Okay, so I want to show you something because I think it's important to show you right now, and that's this. Before I started driving the car and then stopped the car, I'm going to output the current speed. Okay, look what happens. Nothing. Meaning the car doesn't know how fast it's going until you move. And that makes sense with our implementation. Look at our implementation. Drive sets the current speed, stop sets the current speed. Since we haven't called either of those methods, we're not moving. We're not doing anything. We don't even have a current speed. But ideally, if you called current speed at the beginning, it would be equal to 0, not nil. So for that reason, Ruby has a thing called an initializer. And in the initializer, we can set the current speed to 0. So this is a special name of a method. It's always called initialize. Okay, so check it out. This car is going 0, then it's going 65, then it's stopping. Now it's at 0 again. You can even put let's output the speed maybe in between, just to verify that like John's not lying to us. Boom, 65 right in the middle. Okay, and the last piece is that initialize, just like everything else, is a method. So it can actually take in arguments too. Let's make it take in a variable called color. Yep, it is a constructor. So anyone that's been in a language before and used a constructor, that's what this is. Antonio, you do still need def current speed, because if you don't, then current speed is not available outside the instance. By default, instance variables are only available inside of an instance. So we're defining current speed to essentially let the outside world be able to access the speed. Think of it like a box, right? A car doesn't let you can't ask a car how many bolts it has, but the car itself knows, like the car itself knows how much windshield wiper fluid there is, but like you have to do work to be able to find out what it is. Okay, so I said that the initialize method can take an argument. I'm going to show you how that works. I'm going to set color equal to color. So what that says is when I initialize you, I'm going to tell you what color you are. And I want you to remember that value in an instance variable called color. We can call it current color to not confuse ourselves. Instance variable called color will be equal to the thing that was passed in. And then we're going to change this drive method. I'm going to change it to driving a color car at, okay. So let's run it. Oh no, what happened? It says that we're given the wrong number of arguments. We're giving 0, but expecting 1. And it says it happens on line 29. So let's look at 29. That's where we're defining our car. Can anyone see what's wrong with defining the car? Color is missing, exactly. What color car? We're driving a pink car. Looks like I have a bug. This should be at current color, sorry. Run it, driving a pink color car at 65. So just to recap what we learned, a class defines the behavior of a thing. The initialize method sets up the initial state of a given object. So in this case, it sets the speed to 0 and it sets the color to whatever you told it to be. So class or instances can have instance methods. That's what these are. And it can also have, instance variables. That's what these are. And it can also have instance methods, which are what these are. They're special methods that live inside of a class that get access to the instance variables. We're able to create a new one and we're able to call the methods on it and interact with it. And it actually remembers things between us talking to it. It's freaking amazing. It's so cool. Okay. I'm going to go through the homework. So the homework, and you're going to do this over the next couple of days because we're not meeting tomorrow. Remember, our next meeting will be on Monday. Same time, 5 p.m. Eastern. I realized that there were people that got confused by the calendar invitation. I want to tell you why. It's because of the programmer's least favorite thing. It's daylight savings time. It's going to switch on the 14th, I think, of March. And when it does that, it's going to make your calendars be off because Zoom, I guess, did not account for daylight savings time when they put the calendar together. But I promise you, we're meeting at 5 Eastern time. So when the times switch, still 5 p.m. Okay, so exercise 1, I want you to create a class that represents a person. People are going to have names and phone numbers. Take those values in via an initializer. Okay, so you're going to make a class called person, and it's going to have an initializer that takes in a name and phone number. And then I want you to implement a dial method on person. The dial method is going to output the name and number of the person being dialed. So it'll say something like calling John at, and then a phone number. In exercise 2, I want you to create another class. This one is called phone book. And I want you to represent a phone book with this. And by doing that, I want you to implement these 2 methods. The first one's called add. Add is going to take in a name and a number. And it's going to place the number into a hash by name. Okay, so just to be really clear about that, the hash that I'm talking about there is going to have a name that leads to, that leads to a phone number. Okay, so the way I want your add method to work I'm going to just briefly show you how it might work. Name, let's say you're taking name and number and add. What it should do is it should create a phone number using phone.new, name and number. And then I want you to put it into a hash. Name equals phone number. So this is roughly how your add method is going to work. You're going to create a new contact and then put it into the hash. And finally, I want you to implement a dial method, which will take in a name. It'll find the contact and call the dial method on the actual person class, the contact that you found. Good luck. It's gonna be tough. It's gonna test your ability to create a class and an object with a constructor. It is a tough one. I don't think it's as tough as the box, but I do think that it is going to push your boundaries, and that's on purpose. You're all here again, and so I think you got the message that you shouldn't be discouraged by things that are difficult. I want you to try your best, and if you can't do it, then come back here and we'll do it together, and then you can try it again after that. There's also in the Slack channel, there are people in there that are willing to help you. I'm willing to help you. Anything you need, we're going to do it. I'm going to sit here for a few minutes and answer questions, but again, I really appreciate all of your time and willingness to go through this and be confused for a while. Confusion is just part of learning. It's fine. Okay. Do we need to have def current speed if we have answered that already? So I'm going to skip it. Is initializers like constructors in Java? Yes, it is. It's the exact same thing. So we have to make a phone class too. You don't have to make a phone class. You're going to have to make a person class and a phone book class. So you think it's more about the context than it is about the phone. Hey, but if you want the challenge, you can make a phone class too. What happens if an instance variable is defined outside of the initialized class and declared in the beginning? Yeah, instance variables can be defined at any point. They don't have to be defined inside of the initialized class. They have to be defined inside of a method, but they don't have to be defined inside of the initialized class, although that normally is where they are defined. Why do we input the color in car.new? It's just extending the example a little bit. So we're talking about giving the car a color when we create it, just to show you how an initializer can take in arguments. The podcast is about beer. It's about this company that I'm starting called beerbroadcast.com. So we get together and we just talk about the beers that we're selling on the site, and they're local breweries and things like that. It's called Good Not Great. We just talk about random stuff. It's not very good. The next one is from Manon. Hello, Manon. Should the add method be person.new and then add that to the hash? Yes, it should. It should be person.new. And then you want to take that and you want to put it into the hash where the key is the name and the value is the contact. And the reason you want to key by name is because we know that the dial method on phonebook is going to need to look things up by name. So that's exactly why we want to do that. Thank you, Justin. I'll see you soon. Can you put the last code back up? Yep. I think this is what you're asking for. And if not, then let me know. Can you define variables in the body of a class? You can, but it's outside the scope of what we're talking about right now. We might cover it at some point, but not right now. I asked because you did phone.new. That confused me. Yes. Yep. You're going to want phone.new, but with a capital P and a lowercase p. Side note, is matrix something specified in Ruby, or is that basically what an array is anyway? A matrix is a somewhat mathematical thing, but so anyone that doesn't want to know about this, it's totally fine. But a matrix is an array of arrays in Ruby. There's no special matrix type. Whatever we initialize in the init function, we should compulsorily define that in the object, right? Meaning like you want to define these methods. I know that's the standard in languages like Java, but that is not the standard here. You're only going to define the methods that you actually expect to be exposed to the outside world. So in this case, we wanted current speed because I wanted to be able to put it here for an example. But if we didn't want to expose current speed, then we wouldn't define that method. I always found that weird in Java that people just like, they add a variable and then they just like add getters and setters for it right away. Next, in Jody says, in the car example, why wouldn't it return nil when there isn't a color? Okay. I think you're saying why, when if I hear don't pass pink, why doesn't it set the color to nil? The reason that it doesn't do that, I think I can try to show you here. Imagine I was calling something like, let's say I was calling array dot. On array, you can call, I'm trying to think of a good example that I can think of. Basically, like if something needs a certain parameter, you have to pass that parameter. They're not optional. So it's not like the lack of something makes it nil. It is required. I'm actually guessing now, thinking about it, that you're coming from a JavaScript background, because in JavaScript, if you don't pass something, it's assumed to be undefined. That's not how Ruby works. If you don't pass something in Ruby, then it's going to throw an error because it's required. So should the second class take instances of the first? No, they shouldn't. I don't want the second class to take instances of the first class. I want them to take the values, and I want them to create instances of the first class. Next, do we initialize all the instance variables in the initialize method? Yes, that's normally how it goes. Like the color we're using. Yep, pink's a great color. Is the concept of private public protected? I don't want to go ahead, so I'm not going to talk about that, but we will talk about it in the future. Can you go over return larger number from yesterday's exercise again? Sure. If there's a particular part of that that you'd like me to go over, please just put it in the comments here. Otherwise, if you just missed it, just go back and watch the recording. Where do we find CodeStar in GitHub? Do you just search the name up when you're already, I think you're talking about code spaces, and the way you find code spaces on GitHub is you have to be part of our organization. If you're not, please just email me and we'll try to fix it. Next question is, are there default variables in Ruby? I'm guessing what you're asking is, are there default arguments in Ruby? There are. We will talk about them eventually, but we're not going to talk about them right now. If there are two classes, person and phone book, what does person and phone book, what does phone.new call? There's actually going to be two classes. One is person and one is phone book. So there is no phone.new. If I wrote that, I'm sorry. It should be person.new, Manon. That's just my mistake. And that explains that question from before. Someone was asking that, so I'm sorry in advance to that person. If they watched the recording, I'm sorry I answered your question the wrong way. Okay, yeah, weekend assignment I went over already, but I'll email it out. Manon, okay, that was you too. So I'm sorry, Manon. I didn't mean to answer your question incorrectly. Okay. Why is the OP okay 4.0 here? Shouldn't it throw an error? I'm purposely trying to use the same name for func and variable. Okay, let's copy your code and let's talk about it. I'm only doing this because it's the end of the course and I think it's interesting. Yeah, so why does this happen? At first glance, you might think that it's happening because name of function is replacing this name of function thing, but it's actually not. The way that Ruby works is when you reference something like name of function, it says, okay, let me find any local variables that use this, then let me find any methods that use this, then let me look up the hierarchy to find things that I might be missing as I go up So like I'll look into kernel, for example, other places up Ruby. So the only reason you're having this happen is because you're essentially shadowing the function name with a local variable of the same name. Anonymous Attendee says, thanks, John. It is absolutely my pleasure. And my pleasure to have you all in the class too. So thank you so much for your time. I'm going to get out of here, and everyone have a great weekend. I'll see you around. Okay, I'll answer one more question. Okay, we got one more. I'm going to answer it. If we make a function of the same name but different inputs, the first one stops working. I looked up function overloading. I got confused. Okay, so same name, different inputs. Ruby doesn't do that. It doesn't work like that. And the reason it can't work like that is because Ruby does not have, it would need to do that based on arity, which it can't do. So it's just not something Ruby does. So yeah, the first one's going to stop working. You're going to get an error, and the error is even going to describe to you that it was given 2 arguments, but it expected 1, meaning you gave it 2, but it expects 1. When you define 2 methods of the same name, the second one overrides the first one. I do love coffee. I don't know how you could buy me one, but if I ever see you in person, I accept. All right, see you all around.